Scroll through any JWST image post or NASA upload and you'll eventually find someone saying it's fake. Looks like CGI, Photoshop, or the classic, if space is real, why haven't we seen it for ourselves? It's easy to dismiss these comments as internet noise, but they point to a bigger issue. People genuinely struggle to believe these images are real. And it's not hard to see why. Space photos don't look like anything we experience on Earth. The colors are intense, the shapes are surreal, entire galaxies swirl in one corner while glowing clouds stretch for light years in another. If you've never seen this kind of imagery before, it feels more like science fiction than science. Add to that the fact that many space photos are enhanced, colorized, or even digitally assembled from data, and it's no wonder people raise eyebrows. Terms like fake, doctored, or artificial get thrown around without much understanding of what's actually happening behind the scenes. Some skepticism is healthy, but this type of doubt often spreads because the tools and techniques used in astrophotography aren't well understood. People assume if it's not a direct snapshot, it must be invented. What they don't realize is that capturing the universe isn't like snapping a selfie. It requires a completely different kind of process, one rooted in physics, light, and data. So the real question isn't, are space photos fake? It's, do we even understand what they really are? When we hear the word photo, we think of something instant. A shutter clicks, light enters a lens, and boom, a snapshot frozen in time. But space photos don't work that way, not even close. What we call space photos are often the result of collecting light, sometimes over hours, days, or even weeks, and that light is not always visible. Telescopes like JWST don't just capture images in red, green, and blue. They detect light in infrared, ultraviolet, and X-ray wavelengths, frequencies far beyond what the human eye can see. What the telescope actually collects is data, numerical information about the brightness and wavelength of light from distant objects. So when astronomers turn that data into an image, they aren't faking anything, they translate it. They assign colors to different wavelengths to help us visualize things we otherwise couldn't see. For example, a gas cloud emitting infrared light might be shown as red, while ultraviolet emissions might be represented in blue or violet. It's a bit like converting sonar into an image of the ocean floor. You're making the invisible visible. Some images are even composites. Multiple filters, exposures, and sometimes even different telescopes contribute to one final product. That might sound artificial, but it's actually how scientists isolate elements, map star formation, and study galactic structure. In short, a space photo is less like a selfie and more like a scientific diagram wrapped in cosmic beauty. It's real, it's data-driven, and it's our best tool for decoding the secrets of the universe. One of the biggest sources of confusion about space images is color. People often ask, if the images are real, why are the colors so wild? And it's a fair question. Some space photos look like abstract art. Neon greens, deep purples, fiery reds, and none of it seems natural. But here is the thing. In space photography, color is not always about what your eyes would see. It's about what your eyes can't see. Telescopes like JWST observe the universe in wavelengths beyond human vision. For example, it specializes in infrared, a type of light we feel as heat but we can't actually see. So when JWST takes an image, it doesn't come back in color, it comes back as raw data. Intensity maps, numbers, graphs. To make that visible, astronomers use what's called false color or assigned color. That means mapping invisible wavelengths to visible colors so we can actually understand what's going on. This technique doesn't distort the science, it enhances it. By assigning different colors to specific elements or temperature ranges, scientists can identify chemical compositions, stellar activity, and gas dynamics at a glance. Think of it like a weather radar. Red doesn't mean the air is red. It means something important is happening at that spot. Sometimes multiple filters are used to isolate different gases like hydrogen, sulfur, and oxygen. Each is assigned a color, and together they can create an image that's both scientifically accurate and visually stunning. So no, the colors in space photos aren't fake. They are translation, a bridge between what we know and what we can finally see. Once a telescope like JWST collects raw data from space, the real work begins. That data, often recorded as streams of numbers and intensity maps, goes through a rigorous processing pipeline before it becomes jaw-dropping image we see online. But this step-by-step journey is where the confusion and sometimes the conspiracy theories really kick in. The first part of the process involves cleaning the data. Cosmic rays, dead pixels, and background noise are removed to make the final image scientifically useful. Then, astronomers apply filters to isolate specific wavelengths, each corresponding to a different element or temperature. These individual layers are stacked to form a complete picture. Next, colors are carefully assigned based on the wavelengths observed. This isn't about making something look pretty. It's about helping scientists interpret what's there. Sulfur might be represented in red, hydrogen in green, and oxygen in blue. These choices are made not for aesthetics, but for clarity and consistency. Sometimes images are stitched together from multiple observations, what's known as a mosaic. Other times, data from different telescopes are combined to create a fuller picture. These techniques help scientists go deeper, uncover more detail, and understand cosmic objects more completely. It's not fakery, it's information layering. But is any of this ever faked? No, at least not in a deceptive way. Scientific institutions like NASA, ESA, and others are bound by strict data transparency. Every image is backed by publicly available data. When illustrations or simulations are used, they are clearly labeled. What might be confused for CGI is usually a composite or rendering based on real numbers. In other words, it looks unreal because the universe is unreal, just in the most authentic, mind-blowing way possible. So no, space photos aren't fake. They are filtered, enhanced, and built from data, but that doesn't make them any less real. If anything, it makes them more incredible because they show us a universe our eyes alone were never meant to see. Some of the best ways to understand how space photos are real and not fake are by looking at the images themselves. Let's start with the famous Pillars of Creation, first captured by Hubble Space Telescope in 1995 and later reimagined by JWST. Hubble's version, using visible light, showed towering clouds of gas and dust. JWST's infrared image, however, peeled back those layers to reveal stars being born inside. Same object, two wavelengths, two completely different but equally valid views. Then there's the deep field and ultra deep field images. These were compiled over hundreds of hours gathering light from galaxies billions of light years away. The result? A snapshot of early universe. You're not just seeing specks of light, you're seeing entire galaxies, each with billions of stars. If that doesn't make you question your place in the cosmos, nothing will. We also have the first ever image of black hole M87, captured by the Event Horizon Telescope. While it's not an optical illusion in the traditional sense, it's built from radio wave data collected from observatories across the globe. The bright ring you see, that's the light being bent by gravity around the event horizon. It's not CGI, it's physics. And let's not forget about exoplanets like WASP-96b or TRAPPIST-1's planets. JWST's observations of these worlds, including atmospheric analysis, aren't snapshots. They are spectra, light broken down into chemical signatures. They are as real as fingerprints, just cosmic ones. These examples prove that space photos aren't about artistic liberty. They are tools, scientific, precise, and rooted in real data. And they've changed not only how we see the universe, but how we understand it. With all the technical discussion about filters, wavelengths, and data processing, it's easy to lose sight of why space photos actually matter. But make no mistake, they do. These images aren't just cosmic eye candy, they are essential scientific tools that have helped reshape what we know about the universe and our place in it. First, space photos allow astronomers to study objects and phenomena that are very, very far away from Earth. We can't fly to a galaxy billions of light years away from Earth, but we can study its light. A single deep field image can reveal thousands of galaxies, each a chapter in a story of cosmic evolution. Through these photos, we've tracked how galaxies merge, how stars are born, and how black holes shape their environment. Second, they provide vital evidence. From confirming the expansion of the universe to detecting exoplanet atmospheres, space imagery backs some of the biggest discoveries in modern science. It was through imagery that we detected the chemical fingerprints of water vapor, methane, and carbon dioxide on planets light years away. These aren't just pretty pictures. They are data-rich documents that fuel our scientific understanding. And third, space photos inspire. They reach beyond the academic and into the emotional. Seeing the Carina Nebula or the Tarantula Nebula in infrared light can spark wonder in a child or curiosity in someone who's never thought much about space. They connect people to the cosmos in a way that words alone can never. So when you hear someone dismiss a space photo as fake or unnecessary, remember this: every pixel in those images is a story, a measurement, a moment captured across vast distances. They are windows into the past, the mechanics of the universe, and maybe even clues to life beyond Earth. Space photos matter because they bridge the gap between imagination and evidence, and sometimes they make the unimaginable feel just a little bit more real. By now, we've broken down how space images are captured, processed, and interpreted, but we can't talk about the claim that space photos are fake without addressing the elephant in the room: conspiracy theories. From flat Earth advocates to anti-NASA crowds, there's no shortage of people who believe space images are nothing more than CGI. But once you understand the science, these claims start to fall apart very quickly. One of the most common arguments is that all images are rendered or computer generated. While it's true that space agencies use computers to process and display data, this doesn't mean the results are fabricated. Raw data from telescopes is available to researchers and even the public. Many observatories offer open source access to their archives. If it were all fake, thousands of independent scientists around the world would have to be in on it, and they're not. Then there is the issue of international collaboration. JWST isn't just a NASA mission. It's also operated by ESA and CSA. The data is used globally by scientists with different agendas, backgrounds, and countries. There is simply no realistic way a hoax of this magnitude could survive the scrutiny of such a vast, decentralized scientific community. The truth is, these conspiracy theories thrive on misunderstanding. They often rely on half-truths, misguided jargon, or deliberately misleading interpretations of scientific terms. And in a world where skepticism can turn into cynicism fast, it's easy to fall into the trap of "it looks too good to be real, so it must be fake." But reality doesn't need our permission to be extraordinary. Sometimes it just is. So, are space photos fake? Not even close. They are the result of decades of innovation, scientific rigor, and the desire to see beyond our human limitations. While they may not be photos in the traditional sense, they are real representations of real data, collected from the furthest reaches of space and carefully crafted into something we can see, study, and understand. These images bridge the gap between the known and the unknown. They help scientists decode the composition of exoplanets, map star formation, and trace the structures of galaxies. At the same time, they capture the public's imagination. The same image that helps an astronomer calculate the mass of a galaxy cluster might inspire a student to study physics or someone to look up at the night sky with new curiosity. What makes space photos powerful isn't just the data. There are stories told in starlight, frozen in time and translated into color, helping us connect with a universe we'll never touch, but one we are undeniably part of. When science and wonder come together, that's not just photography, that's magic backed by math. And if that still seems too good to be real, just remember, the universe doesn't fake beauty, it just is beautiful. If you found this video eye-opening, or if you ever stared at a space photo and wondered, how is this even real? You're exactly who we made this for. So hit the like button, subscribe for more mind-expanding content, and tap the notification bell so you never miss a journey through space and science. Got questions, theories, or thoughts? Drop them in comments. We read every single one. Thanks for watching, and remember, keep looking up, because the universe has so much more to show us.